All right, welcome to our 10th and final video in our flipped classroom series. I've started you out today with a couple of warm-up problems that are multiple choice to look like ACT problems or whatever. So if you'll go ahead and try number one now. It really should only take you a minute or so, if that. So go ahead and try that. All right, this asks us to add two complex numbers together. Remember, a complex number has both a real part and an imaginary part. So this expression is one complex number. This expression is another complex number. When we add complex numbers together, we're combining the real parts and we're combining the imaginary parts separately. So 3 plus 8 for the real parts would give us 11. And then negative 5i plus a positive 7i is a plus 2i, which is going to match up with answer choice B. Very much like treating I as a variable and combining like terms. And subtraction would work the same way. All right? Your second warm-up is a multiplication problem. So see if you can remember how to multiply those complex numbers. Okay? Again, this looks like FOIL, and we start by doing a process of FOIL. Multiplying 3 times 6 is 18. Then our outer terms, 3 times a negative 7i, 21i. 2i times 6, a plus 12i. And then 2i times a negative 7i would be minus 14i squared. We start to combine our like terms. We have two imaginary parts in the middle we can combine. And then we have one more step to simplify here. So we FOIL and simplify like FOIL first. But then remember, even though we treated I like a variable, I is not actually a variable. I is the square root of negative 1. What that means is that I squared is negative 1. So our last step of simplifying here will be to make I squared negative 1. All right, that gives us a plus 14 on the end, which we can then add those two together. We get 32 minus 9i, which is answer choice E. Okay, so again, multiplying with FOIL, remembering that I squared is negative 1, and like the little thought bubble up here last time to help you remember that. And then combining finally into an a plus bi, that complex number form that you're going to see. Okay? So we've learned about what complex numbers are and how we add and subtract and multiply them. Last step then is how do we divide two complex numbers? All right, I have a sample problem here we're going to work through together. Now, dividing complex numbers, almost not what you would expect. Maybe you'd expect we divide the real parts and divide the imaginary parts. That's not what we do. Division of complex numbers actually is really like multiplication. It's like multiplying twice. I'm going to show you how we do this. The first thing we need to do is multiply both the top and the bottom of this fraction by something. And it's something called the conjugate. All right, that's a new term for us. The conjugate of a complex number. All that is taking a complex number like 2 plus 3i here, changing the sign that's in the middle of it. So the conjugate of 2 plus 3i is 2 minus 3i. And what we're always going to do to start these problems is we're going to multiply by the conjugate of our denominator. We're going to take what's on the bottom, change that sign in the middle. So 2 minus 3i. We're going to multiply the top also by 2 minus 3i. So the numerator is also multiplied by 2 minus 3i. By multiplying the top and the bottom by the same thing, we still have the same fraction. We still have the same expression. We haven't changed the value of it. But multiplying both the numerator and the denominator by the conjugate is going to help us simplify this problem. Right? So what we've created now really is two multiplication problems. We're multiplying the two numbers on top, and we're multiplying the two numbers on the bottom. All right? I'm going to do the denominator first so that you can see the value of why we use the conjugate and why we always can simplify a problem by doing that. So I'm going to multiply 2 plus 3i times 2 minus 3i. I'm going to do that over here with our FOIL, 2 times 2. Then our outer terms, 2 times a negative 3i. positive 3i times 2, and then 3i times a negative 3i. Get minus 9i squared there. Now, take a look at what happens when we start to combine this. Look what happens with the outer and the inner terms when we FOILed. We have a negative 6i plus a 6i. So guess what? Those cancel each other out. Those are gone. And as we start to simplify this, all right, the denominator becomes 4 minus 9i squared. All right? Outer and inner terms are gone. Now, we know that the I squared is equal to negative 1. So we're going to make this 4 minus 9 times negative 1. I'm going to pick that up on the next board so we can finish up the problem. But what you can see is that by multiplying a complex number by its conjugate, when we FOIL and we combine like terms and we simplify the fact that I squared is negative 1, what happens is we've turned this denominator into just a real number. There's no more imaginary part to it. There's no more i's. That's going to help us simplify our answer a lot. Right? Now, we're going to do the same thing on top. We're going to multiply here. 4 times 2. 4 times negative 3i. Negative 5i times 2. Negative 5i times negative 3i. So we have plus 15i squared. Combine our like terms in the middle. All right. And then I have my 15i squared, but I know I squared is negative 1. All right. Now, nothing special about the numerator. The numerator is just like multiplying any two complex numbers. We always want to get the denominator times its conjugate so that we can write our final answer very easily. By eliminating all the imaginary numbers in the denominator, it's going to be easy to write our answer. So make sure you've got all that written down, because I'm going to have to take this down and then move on to a new board, because we're out of room here. These are longer problems because it's basically a division problem. It's like doing two multiplication problems together. All right? So we've got that. And we're going to move on. I'll just rewrite what we had there in that last step. We had 8 minus 22i, and then 15 times negative 1 on the top. And then the bottom, the imaginaries had canceled out. And we had 4 minus 9 times negative 1. All right? Now let's simplify. All right? So we have 8 minus 22i minus 15 on top, and just 4 plus 9 on the bottom. So the numerator becomes negative 7 minus 22i over, and our denominator is just 13. All right? Now our final step here is to write this as a separate real piece and a separate imaginary piece. We want that answer to look like that a plus bi that we've seen in complex numbers before. So since we're dividing the numerator by a single term here, just by the 13, we can think of it as being two smaller fractions. We can have negative 7 over 13, and then minus a 22i over 13. And that's how we're going to want to write our final answer, with the real part and the imaginary part separated out. Okay? So that's what our final answer is going to look like. It does have fractions in it, but by using that conjugate, we've been able to simplify that a lot. So again, and I'll take you through the whole process just to review real quick. You're always going to use the conjugate of the denominator. Take what's on the bottom, just going to switch that sign in the middle, multiply both the top and the bottom by that conjugate. Okay? Use our multiplication process, substitute the fact that I squared is negative 1, and then go and simplify the rest. All right? By using the conjugate, the denominator will always just come out to be a real number. In this case, it was 13. So then at the end of the problem, we can just do the real part divided by 13, the imaginary part divided by 13, and get our final answer. And that's how we divide complex numbers. So you now know what complex numbers are. You know how to add, subtract, multiply, and divide them all. All right? I want to thank you all for going through this lesson group with us for these 10 videos that we've done. I hope that you found that it is useful. It's a little bit of something different. We're going to get some official feedback from you in class, but I just want to thank everybody who's watched and listened to all my lectures and listened to all my jokes and watched all the tennis balls and the footballs and the different colored markers. And I really appreciate your hard work, and I will see you all tomorrow.